Okay, so our today's lead codes question is largest odd number in a string, where we need to find a largest odd number if it exists in a string. For example, there's a number called 52. Example is a number called 52. If we iterate in a number, we find that there is only one possible odd number, which is 5. And if we take a number as 426, as we can see, there is not a single odd number that's there in this number. And if we see our another example, 35427, 35, there are multiple odd numbers in a string. Like, I think my screen is not shared. Okay, so our today's lead codes question is largest odd number in a string, where we need to find a odd number that's having largest value that exists in a string in a order. Like, we need not to check any subsequence or anything or any combination. So for example, in this example 52, if we see in 52, in a string 52, there's only a single odd number that exists, that's 5. And if we see another example as 426, in this string there's not even a single odd number, so yeah, it's having 0 odd numbers. And if we see another string like of 35427, there exists multiple strings with odd numbers like 3, 35, 35427. So we need to return largest among all, which is 35427, which is the number itself. So how we can approach this problem is, first of all, we can iterate through our through our right side, and check if there's a single number that's odd. And if that's odd, we can return our string from the 0th index to our ith index. So let's try it. If we find a odd number in a string, then we can directly return it. Else, if it's not found, then we can return an empty string. So let's try running it. So yeah, as we test is the first, let's try submitting it. So yeah, it got submitted. Okay, so now to use Sangam.
So here's the question that we have been asked today in today's GFG POTD is that there is an array that is given to us, and there are two integers that are given to us. The first one is L and the second one is R. Literally, these are just the limit that we have to follow. Now, among the array that we have been given, we have to found the subarray in which the maximum element should be smaller than R and greater than L. Now, what does that mean? So, if you observe it in this subarray, elements are 2, 0, 11, 3, and 0. Yeah. Now, lower limit is 1 and upper limit is 10. So if we observe it carefully, first array would be our 2 because it only includes only a single element. If you observe it, 2 is greater than 1 and it is also smaller than 10. So therefore we are including it. Now The second array that we can form is 2 0, because in this array the maximum element is what, 2, and it is already following the condition. So therefore this is our array. Now if we consider 0 as an array, then we can find that 0 is smaller than 1. So therefore we cannot include this as our subarray. So we will move forward. Then we will approach at 11. Here the maximum element is what, 11, and it is already bigger than what, 4. So therefore this cannot be included. Now we move on forward. We can see that we are approaching at 3. Okay, and 3 is greater than L and smaller than R. Therefore it is included, as you can see here. And the same goes for 3 and 0. 3 is greater than, therefore maximum element is within the limit. But if we approach only the last element, if we include this in our subarray, then we can see that 0 is smaller than L. Therefore, now let's just understand this question in terms of logic so that we can actually solve it and submit our code. So this is the subarray that they have given to us. Now one thing that I have understood is that if there is a bigger element in the subarray, as you can see it is, what we are going to do, we are going to simply ignore this element. Okay, and we are simply going to take these two subarray and we will work our operation on these subarrays. Okay, that is the first thing. Now if I am finding a smaller element in my subarray, this is a smaller element and this element is within the limit. So if I am finding the smaller element within the subarray, I should just find the subarray which include 0 as the biggest element. Okay, in this case it would be 1. Then I should find the subarray in which 2 will be included. So we can see if we are including this range, then the subarray that we can get here from 2 0 are either 2, either 2 0, or either 0. Yeah, and the subarray we are going to get from the limit of only 0, from including the element 0, is what? If we conclude it, the subarray we are going to get is what? 0. So out of this count, if we just remove the count of the smaller element, we can simply get our answer, which is 2. So these are 2. If we simply remove this one, this will be our answer for our 2 0 window. The same goes for the 3 0 subarray. So if we see clearly, 3 0 is a subarray and the number of 3 is the array, and the number of subarray that we can form from this array are 3, 3 0 and 0. Now if we only include 0, because this is the smaller limit, it is actually smaller than L, and 0 is actually smaller than L, therefore we are not including it. So let's just count the number of subarrays in which 0 would be the maximum element. So we can see that only it, in this case it will only be 1. So take the count of the subarray in which 3 will include. So here it is 3. Take the count of the subarray in which 0 will include as the bigger element. There are only 1. So just subtract it out and add it to our answer. 2 will be our answer. And 3 and 3 0 will be the resultant subarray that we want. So this is the way we are actually going to move forward in order to solve this problem. This subarray that is given to me, or there is an array that is given to me. This is the array, okay, and its length is, let's say, n. Then the number of subarray that we can form out of this array, there is a formula we can apply, and that is n plus, no, multiply, it will be multiply, and then is n plus 1 divided by 2. This is the value. So let's say if the, as we have already included, if there are 2 elements in our subarray, then by following this formula, 2 multiplied by 3 divided by 2, what we are going to get answer is 3. And you can see that is what we are getting when we are including two numbers 3 and 0. The subarray we are forming is 3, then we are forming is 3 0, and then we are forming is 0. So the answer is what? 3. So this is the formula that we are going to use in order to generate the subarray. Now let's just move forward to understand the logic of this question. So now let's just assume this is our subarray on which we are going to do our dry run. Okay, there are three variables that we have to consider. First one will be that answer variable, which will store the answer. The second variable would be the s, which will be the smallest. Small. Let's just consider it from the ideology right now. I will explain later on that why these are taken in such a manner. Then there is the L, which is the largest element. Okay. Now, we are going to do a for loop. It will be an iterative loop and we are simply going to move forward in this array. So first of all, we are going to reach at what? So let me just clear this thing out at the moment so that it become easy for you guys to understand. Yeah. Now, so we were, yeah. So first of all, we are at 2 and then we are going to check that is 2 greater than, and there is a condition that we are going to apply, and that condition would be that if the given element, that is array of I, is it is greater than R, that will be the first condition. The second condition would be that array of I that is given to me, is it smaller than S, that is the smallest element. Okay, or array of, or third case would be that it is within the limit. Okay, so that would be the our bigger element that is given to us, and this will be our like left side element, this will be our right hand limit. Okay, now let's just move forward. So first of all, we will be at 2. Then we are going to check in this condition. The first condition is that is 2 greater than R. In this case, it is what? 10. And left, in this case, you can see that 2 is not greater than R. So this condition is not met. Then we are going to see that is 2 smaller than 1. Then we can see that this condition is also not met. Then we are going to move forward toward the third condition. And that condition is what? Condition is that from the answer subtract the subarray of smaller element. Okay, this is the condition that we are going to follow. Now understand it. Right now, what is the value of our small? Initially, it is 0. For the large, it is also 0. So what they are saying to me is that from the answer, just decrement the value of subarray which are formed as 0 or the smallest element as the largest element. So what we are doing is we are just finding the subarray that we can get out of the smaller one divided by 2, and we are just subtracting it from our subarray. So after following this approach, the answer would be what? If you see it carefully, right now it is 0 and s is also 0, this one is also 0, so when ultimately it would be like 0. So after doing the first traversal, my answer is what coming out to be 0. Okay, then after that there is a next operation that had been done in this case, and that is take smaller as 0 and increase the value of count will lead by 1. Okay, so what does this means? Yeah, so what does this means? Increment the value of L by 1 and keep S as 0 and answer would be 0. Yeah, then we are going to move toward the Z, this second element. Then here we can see that the given element, if we follow it carefully, it is actually following the second condition, that is 0 is smaller than 1. And if this condition is applied, then the second thing that we have to do is increment the value of small and increment the value of valid. The thing that I am going to do in this case is increment the value of small, which will become 1, and increment the value of valid, which will be 2. Then we are going to move forward. Then here we also reach again 0. The same condition would be applied. Increment the value of small by 1 and increment the value of L by 1. So it will become 3. Now we approach at what? 3. So after we approach 3, what was the condition? 3 is actually not greater than 10 nor 3 is smaller than 10. Therefore the third condition would be applied. And what would be? That from answer, which right now is what? 0, we are going to subtract the subarray in which smallest element is considered. So as you can see right now, the value of the smallest element is what? 2. Yeah. So find the subarray which will be formed by 2 elements. So if you observe it carefully, it will be 0 minus 3 and it will become minus 3. Now, why I am performing this operation? What I am doing here is, from this valid window, the subarray that I am going to form is a certain number. So if I just remove the subarray in which 0 and 0 are going to be the only element, I can find the subarray length of valid number. So you are seeing, so if it is 2 0 0 3, then the subarray that we are going to get is what? Length is 4 here, for from 2 to 3. So 4 multiplied by what? 5 divided by 2. The subarray that is going to be generated are what? 10 from what? 2 0 0 3. Now the subarray 0 and 0, whatever they are going to be formed, these subarrays are not valid. So we have to remove this subarray from the number 10. How we are going to do that? Calculate the length of this. It is 2. So 2 multiplied by 3 divided by 2, we are going to get is what? 3. So if I remove these subarray length from the full length, I am going to get the length of the valid subarrays. In this case would be 10 minus 3 would be 7. And that is the operation that we are applying on this whole code via this logic. So what we are doing here is, given array, okay, find the value of the sub array which include the elements that are valid. In this case it is 2003. Okay, and that value will be 10. Then find the sub arrays which include the illegal element. In this case these are 2, and the sub array we are going to get from these are 3. Then simply delete those subarray values from our given length, and ultimately we are going to get the value of valid subarrays. So 7 are the valid subarrays that we are going to get from 2003. Now the condition comes that, let's say this is our subarray, and yes, if the smaller element are available, then yes, we can actually decrement that. What if there is a largest element? So as I already told you, I already explained to you guys in here, that within a given subarray, this is our array 20 11 30. Okay, if we find any largest element, we are simply going to exclude it and take the subarrays that are around it by on a singular level. So the same thing, same principle is what we are going to apply in here too. Okay, after we have found this length, once we encounter that our value is greater than r, then what we are going to do, we are simply going to make our sum here 0, make our valid here 0, and simply going to move forward with the similar operation that we have done in these case. The similar manner we are going to get here what? 7 as an answer. The similar manner here we are getting 7 as an answer. We can simply sum them and return them as our overall answer. Okay, so what is the logic? If it is smaller, if the value is smaller, then find the subarray, find the subarray of it, and decrement the subarray from our answer. Okay, that is what we have done. Now if the value is valid, then do what? Then simply add that subarray length to our answer. Okay, and if it is greater than, that is in case of 11, it is greater than, then the thing that we are going to do, we are simply going to start over. Okay, so if I'm finding a valid, just add this to my subarray. If I'm finding it smaller, just decrement it from my answer. And again, if I'm finding valid, just add this window to my answer. And if I'm finding a bigger element, then restart over. Make small 0, make valid 0, again move forward in the similar manner. So this will be valid, it will be added. These both are invalid, these will be subtracted. Then the 3 will be here, so it will be added. And this way we are simply going to solve this problem. So let's just move out to the code. So as you can see, there are three variables that we have taken. First one will be answer, the second one will be small, and the third one would be valid. Simply valid means that the given number, let's say a of I, is actually smaller than r, and a of I is actually greater than l, greater than or equal to l, so such that it is actually in a valid window. Okay, so this one's logic is this. Now for in case of small, we are just taking a count of values who are smaller than the L. That is what we are doing in this case. Okay, so first of all I'm going to traverse through the loop, through the array. If the value is greater than R, simply find the valid, simply delete this invalid, and again start over from small and valid to 0. If I'm finding the value which is smaller than L, just simply increment the value of small, simply increment the value of valid. And if I'm finding a value which is valid, then simply first of all decrement the value of small from it, make small 0 and move forward. Then after that, at last, what we are doing here is, at last, here, before returning the answer, just find the valid and then delete the invalid and simply return this as our answer. So this is the way we are actually going to solve this problem, and if we just submit it out, it should work perfectly fine. As you can see, it is working perfectly fine. So with that guys, today we have solved both GFG and Leetcode questions of today, POTD. And with that, over to you, Shivam.
So yeah guys, thanks for joining with us. We will catch you up tomorrow.
Yeah guys.